Welcome to my video on mean, variance, and standard deviation calculations with digital micrometer measurements. So in this video, I'm going to use a digital micrometer to take 8 measurements of the diameter of a 3/4 inch hardware drill bit. And what I want to show is I want to show the actual calculation from the measurements of the mean, the variance, and the standard deviation. The idea here is to use real world examples, and I'm going to show you how I actually took the measurements so you can get a little bit of understanding on that also. Before I get into that, this is the mean, the formulas that we're going to be using, and I've covered these before in a previous video. I'll put a link in the back to that video, but here's your basic definition of the mean. Mu is equal to 1 over the number of samples that you're using. You sum all of the individual observations. In this case, it's going to be drill bit measurements. That's the x of I, and you divide by the number. The variance tells us a little bit about the spread of the data. And so we sum now, except we take the individual measurements minus this mean that we just calculated, square that, so it makes it a positive number, and divide it by the total number of observations or measurements. Now the standard deviation, it's just the square root of the variance. And so the reason the standard deviation is used is it gives you the same basic information as the variance, the spread of the data points, but it's in the same units as the data points. In this case, I use an inch micrometer, so it's going to be in inches. It's a 3/4 inch hardware store drill bit, and right in here, about 3/4 of an inch, or it should be. Down at the bit area, it's usually a little bit smaller. It's a little bit bigger, just a few hundredths of an inch smaller. This is the bit area, the cutting. These are the fluted areas that does the removal of the waste once it's been cut. And then this should be the full 3/4 of an inch. That's what I want to take several measurements of this and see what the standard deviation is of that. Okay, first thing I'm going to do is I'm going to turn on my micrometer, put it in the 0 position and 0 it. So I get that. Now, I'm going to be measuring this area right here, right before it turns into the shank. 7545, 757, 7495, 7485, 7490, and 7485, 7495, 7505, and then the last reading is 7480. So there I have my measurements. Now I'm going to calculate the standard deviation of this and the variance and the mean and see what I come up with. Okay, now with these measurements, here are the 8 measurements I took right here. And these are all in fractions of an inch. So they're all in inches, so 0.745 be the first measurement. So there's my basic data. Now I use the summation feature in Excel, and I just average this out. And so our mean, our average, is 0.7506 inches for the 8 observations or measurements. Now in this column, I calculated back to the formula for the variance and the standard deviation. X of I is the individual measurements minus the average, which was here. Squared that number, and so that's what each of these entries in the column represent right here. You can see I probably need to extend this out to give you more digits because of very small numbers, and they just rounded to 0 in 5 places. There are actually more decimal places done in the Excel calculation. So now if I sum these all together, I sum this column right here to get this number right here, the 0.00008, with some more digits not shown. And then the variance is that summation of all those differences squared divided by the number of observations, which is 8. So that's our variance, is 0.00001. Now if we take the square root of that number, we're going to get the standard deviation. So our standard deviation of these observations is 0.0031. That's in units of inches. Now here's our results. There's our 8 measurements again. And we just calculated that a second ago, so we've got the mean of 0.7506, and the approximate lines here is because everything is not, they're all continued fractions, they're not whole numbers. And the variance, we calculate that's 0.0001, and the standard deviation is 0.0031 inches. So let's plot that. So this graph shows the diameter in inches. This red line here represents the average, that 0.7506. And these are the individual measurements, and you can see how they kind of just all weren't exactly on. That's the whole idea of the standard deviation and the variance and the mean, is it tries to explain the numbers. And this dotted line right here and right here, this is the standard deviation plus the mean. So that's going to be one standard deviation plus the mean. So that tells you how the data, as you can see, most of the data, and we learn in statistics later, that it is plus or minus one standard deviation where most of the information is contained. That's what tells us something about the standard deviation. It tells us where the observations or measurements are located. And so this is the mean minus one standard deviation, is this line right here. So that groups the data into plus or minus one standard deviation. So what can we get out of this? The drill bit measured very close to its nominal value. It was machined to 0.75 is a 3/4 of an inch drill bit, and the upper portion near the shank is where you get the full dimension of the drill bit, and the average 0.7506 inches, very close, and the variability of the measurements was small. We had a standard deviation of 0.003 inches, which is actually 3/1 inch. And so this demonstrates how the mean, variance, and standard deviation can describe real-world measurements. I hope you got something out of this and learned a little bit about combining real-world measurements with calculation of the mean, variance, and standard deviation. If you would, give me a like, thumbs up, subscribe to my channel. Thank you for watching.